We're ready to do our second example of graphing a linear inequality. And so our steps are to graph a boundary line and decide whether it's a dashed line or a solid line, and then use a test point to figure out which section of our coordinate grid we're going to be shading in to show all of the points that are included as possible answers. So this inequality comes to us as 2x minus 3y is greater than or equal to 6. I'm going to rearrange that into slope-intercept form. So I'm going to subtract 2x from each side, so I have negative 3y is greater than or equal to negative 2x plus 6. And now I'm going to divide each side by negative 3. When we multiply or divide both sides by a negative number, we switch our sign. So I'm going to do that. I'm going to divide by negative 3. I'm switching my sign. So I have 2/3 x minus 2. My inequality statement in slope-intercept form is y is less than or equal to 2/3 x minus 2. My slope here would be 2/3, and my y-intercept is negative 2. All right, next I need to decide, do I have a dashed line or a solid line? So just like having an open circle or a closed circle when you're just doing a regular inequality on a number line, if I can include the points, if I have an equals part to my statement, then I'm going to use a solid line. Okay, so now I'm just going to plot that the way I normally would. I'm going to start at negative 2. My slope is up 2 over 1, 2, 3, up 2 over 1, 2, 3, and I will use a solid line to graph this. Okay, solid line. And so now I have to decide what test point I'd like. I will almost always choose 0, 0 if that is not part of my line. So 0, 0 is my test point that I'm going to use. Let's see if it works. We're going to test with 0, 0. If I plug in 0, 0, always go back to your original inequality statement or your original equation. So if I plug in 0 for x and 0 for y, I get 0 is greater than or equal to 6, right? That is not true. What that means is my 0, 0 point is not one of the solution points. So this is not my solution. The upper part of that line is not my solution. This is my test point that doesn't work, and so I realize every other point down here does work. Okay? And if you want to just double check and make sure that you believe what you have done, you can just pick any point here. So I might choose, I don't know, 3, negative 2. So I'm going to test again and just make sure. Test with 3, negative 2. And if I plug that into the original statement, I have 3 times 2. Sorry, I wrote that backwards. It's really 2 times 3. Minus 3 times negative 2 is greater than or equal to 6. So I have 6 minus negative 6, which is 6 plus 6 is greater than or equal to 6, and sure enough, 12 is greater than or equal to 6. So I know that's true. That means my test point works. Okay, so that means that anything that I've got shaded over here, anything shaded below my boundary line, would be a solution to this inequality. Okay, so determine which ordered pairs are solutions to this inequality right here. 2x minus 3y is less than 15. I could graph this and shade it and then see if each one of these points fell in the shaded region, or I can just plug in the x and the y and see if my statement is true. I think the second thing I said is going to make more sense. So I'm going to just plug in. If I have 2 and 5, this will be 2 times 2 minus 3 times 5 is less than 15. So let's check all of those. 4 minus 15 is less than 15. Negative 11 is less than 15. This is true, so yes, that works. If x is negative 1 and y is negative 7, I end up with 2 times negative 1 minus 3 times negative 7 is less than 15. Negative 2 plus 21 is less than 15. 19 is less than 15. Nope, that's not a true statement, and so this guy does not fall in the solution set. X is 3, y is negative 4. That means 2 times 3 minus 3 times negative 4 would be less than 15. 6 plus 12 is less than 15. And I get, oops, 18 is less than 15. That is not true. not true, so that is also not in my solution set. You can also type an inequality statement into Desmos, either one of these. You could type straight into Desmos. Desmos will give you a dashed line or a solid line appropriately, and then will also show you where the shading is. So that's a place that you can check your work. Okay. All right, so once we know how to graph any inequality, we're going to think about what we do if we have a system of linear inequalities. So, up until now, we've been working with systems of equations, and we would find the exact ordered pair that works for two equations in a system, if there is one single answer. When we worked with a system of equations, we would have two lines intersecting if we had one point. When we have systems of linear inequalities, we're going to have two shaded areas on our coordinate plane, and where those overlap, the overlap section is going to be the solution set to that system of linear inequalities. Okay, so steps for solving a system of linear inequalities. If we're doing this by graphing, we're going to graph the boundary lines. We're going to make sure we know whether you're using a dashed line or a solid line, and evaluate a test point. Okay, and we're just going to shade the region for each line, and then we're going to see where those two shaded regions overlap. So let's just show you how this works. Again, with our system, we have an open curly brace there that tells us we have a system. All right, my first statement here is y is greater than 1/3 x. So I know that my m would be 1/3, and my b would be 0, right? That's going to go right through the origin. So here I am. I'm going to go up 1/3. Up 1/3, and I will back myself back up right there. Okay, next I want to think, is this a solid line or a dashed line? It's dashed, right? It's dashed because I don't have any equal sign here, so I'm going to do a dashed line to show this boundary. Dashed line to show my boundary. Okay, now I'm going to use a test point. So I'm testing the upper inequality statement, and of course I'm going to, I can't use 0, 0 because that's right on my line, so I need to choose something different. Since I have a fraction that has 3 as the denominator, I am going to choose an x that's a multiple of 3. It's just going to make my life easier. So if x is 3 and y is 2, let's just see, that would be at 3, 2. So this is my test point right there. Okay, so let's test it. If x is 3, then y is 2. 2 is greater than 1/3 times 3. Let's see if this is true. 2 is greater than 1. That is true. So that means this test point is true. Okay, so my shading, if I were just doing a normal linear inequality, this is my shading, right? Everything above that dashed line. All right, next, I need to deal with my second statement here. X is less than 1. This is also going to be a dashed line, right? So x is less than 1. I know, I don't have a slope per se. It's not a slope y-intercept, right? It's not a y equals mx plus b format. So this is a special case. This is a Vux line, yeah? And so it means it's a vertical line. X has to be less than 1. So I'm going to draw my line, my dashed line, at x equals 1. So any one of these points, as long as x equals 1, that is the line that I'm thinking about. So I'm going to make it a dashed line. Okay, dashed line right there. And I have to decide, am I looking at the left side or the right side? So I will still take a test point. I'm going to use 0, 0. So if I test with 0, 0 on my green line, then x is 0, right? 0 is less than 1. There's no place to put the y, and that's okay. It doesn't matter. I'm going to plug in my x. 0 is less than 1. Check. That means that my test point 0, 0 works for this green line. What it means is that everything on the left side of the green line is true for my second inequality. Okay, so I'm almost there. Look at this section in here. Can you see that this is shaded by both of my colors? this area right here. And so a lot of times the way we'll show this, I go all the way to my line, we'll say S for solution. This is the solution set, right? It is marked by this boundary dash 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 right here, and it's marked by this boundary dash 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 right here. Okay? So any point inside that double shaded area is going to be a solution. So I'm going to check some point in between here. I'm just going to double check and check my work now instead of checking a point to see how to shade everything. Something that is in the shaded region for both is going to be -1, 2, 3, -3, and let's see, +4. I'm going to use that as my test point, -3, 4. Okay, I'm going to check it in my top inequality statement. 4 is greater than 1/3 times -3. 4 is greater than -1. Check, that's true. Okay, I'm going to check it down here. If x is less than 1, then I'm going to plug in the x. -3 is less than 1. Well, that is absolutely true too. Okay, so you've graphed your first system of linear inequalities on a coordinate grid. Every single time, what we're going to do is look at our inequality statements and decide whether we need a dashed line or a solid line. We're going to rearrange in slope-intercept form so that we can figure out what our boundary line would be, use a test point so that we know which direction we're shading everything, and then when we have figured out our double shaded region, we're going to test one point in that double shaded region to make sure that it is true for both inequality statements in the system. All right, so we're going to do this one more time. I'm going to rewrite my inequalities in slope-intercept form. So this will be y is less than -x plus 5. So my slope is -1 and my y-intercept is 5. So here I am at 5, down 1 over 1, and so on. Before I draw my line, I need to figure out, is it a dashed line or a solid line? It's dashed. I really do write dashed on my paper a lot of times because I am notorious for forgetting and then drawing a solid line, and then I have something in ink that I have to try to figure out how to fix. Okay, I have a dashed line right here. All right, now I need to figure out, am I shading above it or below it? It is y is less than all of that stuff, so it should be below, but I'm going to double check my test point, 0, 0. I love my 0, 0. If I plug that into the original equation, I get 0 is less than 5, and that is true. So I'll be shading to the lower left side. Okay, it is helpful to use two colors or to use colored pencils or to try to shade lightly so that you can see your overlap. Pencils are really great in case you have to erase. Okay, I'm going to do my second inequality statement. That is also dashed. Remember, it's dashed because it doesn't include the equal sign. This will be -2y is less than -x plus 6. Divide everything by -2. Since I'm dividing by a negative, I switch. Y is greater than 1/2 minus 3. 1/2 x. Yes, I do know that I need my x. I did not lose it. That is y is greater than 1/2 x. Make it legible. Minus 3. Y, remember I switched my sign because I divided by a negative. Y is greater than 1/2 x minus 3. Better. Okay, so I'm going to plot starting with -3, and then my slope is up 1 over 2, up 1 over 2. It's a dashed line, I'm going to remind myself again. Okay, and now I'm going to use my test point on my second inequality statement. So if my test point is 0, 0, then I get 0 minus 0 is less than 6. Totally true. So 0, 0 works for that also, and it means that I'm shading everything above my dashed line. Now remember, I'm shading everything that goes on forever, ever, ever in this direction, right? So this part right here is only shading green. Everything below this boundary line and everything above this boundary line is what I'm going to include as my solution. So here is my solution set. We like to do a check, just pick one of those points in there, and so I'm going to choose, why don't I say 2, 1, just for kicks. You can choose anything you want. In my first inequality statement, that would be 2 plus 1 is less than 5. 3 is less than 5, check, that is true. 2 minus 2, right, if I'm plugging in 2, 1, 2 minus 2 is less than 6, and 0 is less than 6, check. That means I got it right. Okay, so we have some more problems that we're going to work on, and you are welcome to try them first, and then pop back into the next video to see how you're doing, or if you want to watch the video and go through those notes step by step, that's absolutely fine too. Thanks for watching.